Hi everyone, this is Yashasvi. I am a third year college student and I've recently cracked Google internship. I did a step internship in this summer, which is 2025, but I got a PPI and I'll be returning again in 2026 as a SUI intern at Google.
So hello guys, with the name of God Ram Ram, we start this beautiful course and lecture of hashing. I am Kumar K. And guys, I want to share something very important and insightful before we start this lecture. Let's say DSA is a very big tree, okay? DSA is a very big tree, okay? It's a big tree, big maze, okay? Like this. So, if you want to become a person who is able to crack Google, Uber, Amazon, Microsoft, who is able to perform flawlessly in hard unseen DSA questions of lead code, code forces, etc., so you will have to reach the top of the tree. But do you know this DSA tree? What are the roots made up of? Roots are made up of the topic called as hashing. So, guys, hashing is a very fundamental topic and a very fundamental concept, and most of the students don't put the amount of focus which is needed to be put upon hashing, prefix, and suffix related structures and algorithms. But in this lecture, I will show you how deep we need to go inside hashing, prefix, suffix, and many variations I will be teaching in this hashing, prefix, suffix course of different algorithms, patterns, tips, tricks, and concepts which are not available in any course in the country. So why hashing is so important? Because in future you will learn graphs, you will learn dynamic programming, you will learn two pointer, you will learn binary search. In all those topics, hashing will be involved in the solution. Many times you will have to use the prefix concept, suffix concepts, and hash map. And you also need to know how to visualize things from I to J, hashing mixed with mathematics, and many more things. Doing that there will be very difficult if you are not already strong in it. So first we will make our hashing very strong, okay, very strong. And then when we do other topics will be easy for us. The secret DSA trick many of the influencers and creators don't share, but I am sharing it with you. So let's start with the question and the lecture number 4, right? Yeah. So guys, see, the question is pretty, like you can understand that we are given an array of numbers. We have to find and print any number with maximum frequency and minimum frequency. Okay. So basically, first let's try to find out the meaning of maximum frequency and minimum frequency. Maximum frequency means what is the maximum number of times a number is coming in the array. Minimum frequency means the minimum number of times a number is coming in the array. So let's take 3, 2, 3, 2, 4, 3. 3, 2, 3, 2, 4, 3. So if I take this array, 3, 2, 3, what was that? 3, 2, 3, 2, 4, 3. So how many times is 3 coming in this array? 1, 2, 3. 3 is coming for 3 times. How many times 2 is coming? 1, 2. 2 is coming for 2 times. Coincidence. How many times 4 is coming? 1 time. 4 is coming 1 time. So guys, these are the set of the frequencies. Now which frequency is minimum and which frequency is maximum here? 3 is the maximum frequency, means a number is coming for maximum 3 times in this array. And what is the minimum? 1. Means there exists some number in this array which is only coming for 1 time. So 3 is the answer for max and 1 is the answer for min. Now guys, next you have to pause the video and you have to answer me. Write the answer in the notebook, okay, for this array. I will not say, you guys have to tell me. This is the array. What is the maximum frequency in this array and what is the minimum frequency in this array? Pause the video, think about it and tell me. Now guys, assuming that you paused the videos and answered it, yeah, so how many times is 1 coming in this? 1, 2, 3, 4, 5. 5 times. How many times 2 is coming? 1, 2, 3, 4, 5, 6, 7, 8, 9. How many times 5 is coming? 2 times. So these are the frequency. What is the maximum possible frequency? 9. So maximum frequency is 9. What is the minimum possible frequency? 2. So minimum frequency is 2. So guys, we just wanted to know how to find the minimum frequency and maximum frequency. Okay, you can count and check 1, 2, 3, 4, 5, 6, 7, 8, 9, and yeah, 1, 2, 3, 4, 5, and yeah. Okay, good. So now all this is going very great. We are enjoying it a lot. Nice, awesome. What is the brute force algorithm? In the interviews, if they ever ask you a question, first always think about the brute force algorithm. So brute force, we can solve it in O of n square time, right? Yes, we can. How? See, I must completed the baby step, step 0, step 1, step 2, step 3 before reaching here. So O of n square algorithm is actually very easy. Okay. What we do is that, let's say you have this array. Okay. You are at index I equal to 0. You are at this index. So in your for loop, I am at I equal to 0. I will go till n minus 1. This is my n minus 1. Okay. Now try to find out my current number is what? My current number is what? A of I. My current number is what? A of I. A of I where I is 0. So my current number is indirectly 1. My current number is 1. So try to find out how many times 1 is coming in this array. So for that I will just put one more extra for loop. One more for loop. J will go from 0 to n minus 1 nested for loop. Now check. Now I am traveling the whole array and I am checking wherever 1 is coming, I am increasing the counter. So current is A of I, count is 0. Now if A of J, I am traveling, now my J is going from start to end. If A of J is equal to A of I is fixed. Or I can say if A of J is equal to current value. The current value is this 1. So I'm traveling from left to right. Wherever I find a 1, I increment the counter. Count plus plus. So 1 here, count plus plus, 1 here, count plus plus, 1 here, count plus plus, 1 here, count plus plus. So once I come outside of this internal for loop, my count value will be what? My count value will be 4 because 1 is coming for 4 times. And I can store it somewhere that A of I came for 4 times. Now, once that is done, now my I will point to 1, which is number 2. Now I will check 2 is coming for how many times in the whole array. And you will come to know that for this count will come as 2. So for each A of I am getting a count number. So I can, if I am getting count number for each A of I can take max of them. Then I will know the maximum frequency. And if I take min of them, I will know the minimum frequency. So it's very easy. I will show you the dry run also one time before we go ahead. Okay. So like 1, 2, 3, 2, 3, 1, 1. Okay. So when I am at 0, 1, 2, 3, 4, 5. Okay. Okay, so when I am at I equal to 0, when I am at what? I equal to 0. I am at I equal to 0, guys. I am at I equal to 0. So what are we supposed to do now? Let's think. Let's really think. At I equal to 0, I will calculate the count for this number. What will be the count for this number? How many times 1 is coming in this whole array? 3 times. Then when my I equal to 1, I will try to calculate count for this number. How many times 2 is coming in the whole array? 2 times. Then when I am at 3, how many times 3 is coming in the whole array? 2 times. 2 again you will count. Yes, that is, you can see now, feel a little bit drawback of this algorithm. When you again reach 2, you don't know whether you have earlier traveled a true or not, because you have come ahead now, right? How will you remember the past? You could remember the past if you stored the element in the hash map and optimized it to O of n, but we don't have a hash map now. So again, 2, how many times is coming? It's coming 2 times. 3, how many times 3 is coming in the whole array? 2 times. 1, how many times 1 is coming in the whole array? 3 times. 1, how many times 1 is coming in the whole array? 3 times. So guys, whatever these values I got now, whatever these lovely values I got, I will just take their, I will just take their minimum. So what is minimum? Minimum is 2 and maximum? Maximum is 3. So guys, minimum frequency and maximum frequency can be printed like this. Now let's check the C++ code, Java code and Python code for it. Okay, let's do that for now and just enjoy the life. Be very happy. You can achieve a lot. So now let's go and let's start the fun process. This is our hashing lecture 4. There are lecture 1, 2, 3 that also will be released. You don't need to worry about that. Okay. So guys, if I am going to teach you in all the 3 languages because C++, Java, Python, all 3 are very, very important. Okay. So let's check this thing, C++ code first of all. Okay. Okay. So, yeah. So hopefully, guys, just like fully focus on the C++ code I'm trying to show you. Okay. So in C++, what we can see is that, see, I took the integer n, this is the array a of n, I going from 0 to n minus 1, took the input, okay. Answer 1, I am declaring it as infinity, answer 2 as 0. Why? Because answer 2 will be the maximum frequency. So answer 2 should start from 0 now, so you can catch the maximum. And answer 1 will be minimum, so start it with infinity, the biggest possible value. 10 raised to 9, because array cannot have any number coming for 10 raised to 9 because array is generally less than 10 raised to 5, 10 raised to 7 size, right? That's why I have taken the maximum number possible as 10 raised to 9, okay? Now, I go from 0 to n minus 1. Now I will count how many times a of I is coming in the full array. I have wrote roaming, it is actually coming. So let me fix it for you. How many times a of I is coming in the full array. So I go from 0 to this. Whenever it is equal to a of I or current, count plus plus. And I take the max of all count, I take the mean of all count. And that's how it gets done. Okay. Now guys, I will show you the similar Java and Python codes as well. Okay, so let's get started. So guys, this is the Python code. Sorry, this is a Java code. See guys, scanner for our input class. Okay. N is also there. Array A declared. A input taken. Answer 1 infinity 0. Okay. This is a homework for you. Why did I declare them as 0 or infinity? You can message me on WhatsApp and tell me. I will be very happy with the hashing lecture number name. Going from 0 to n, now I will calculate how many times the number I has come. So I go from 0 to n minus 1 and I count it and min and max of the count, guys. Similar, very similar will be the Python code and Python code also. Now let's check out how is the Python code. Okay, so guys, now let's check the Python code. So here we go. The Python code for maximum and minimum frequency is here for you, which you can easily observe. Okay. So you can see that enjoyment is going on. Life is just enjoyment, right? Now let me push it to the side. Okay, yeah. So guys, input taken, array taken, input 0 to n minus 1, answer 1 infinity, answer to 0. You can tell me personally on my WhatsApp message, why is this infinity and 0? You go from 0 to n minus 1. You count how many times that number is coming by running one more loop. You take minimum of all counts, maximum of all counts. You then know the minimum, the frequency, maximum frequency. In 1, 1, 2, 2, 3, 3, 2 is the maximum frequency. And 3 coming one time is the minimum frequency. So minimum is 1, maximum is 2. Answer should be 1, 2. It is 1, 2. So guys, for now, you have understood how to print the maximum frequency and minimum frequency. But now question is saying that also print a number which has the maximum or minimum frequency. They want you to print that number as well. What will you do? Very simple. Just a simple change in your maximum condition and you can track that number also. Earlier, what you were doing, if this was your, what were you doing? You were just saying that the maximum frequency is what? 5. 1, 2, 3. 1 coming 5 times. But now you have to print that element also. You have to print the maximum frequency element also. Which is the guy which has 5 frequency? 1 is that guy. So now you have to print 5 with 1. And what is the minimum frequency element? Minimum frequency element, either you can print 2 or you can print 3. So answer will be 2, 2. 2, 2 means the minimum frequency is 2, right? And which number is coming for 2 times? 2 is coming for 2 times. Or the answer could be 2 comma 3. Minimum frequency is 2 and 3 is also coming for 2 times. So there can be multiple possible answers. But question is saying you print any number which is having minimum frequency or maximum frequency. We are okay with it. So before I go you and show you the codes, you pause the video and write the answer for it in your book. Okay. What is the maximum frequency element? MF. And what is the maximum frequency and what is the maximum frequency element? I want you guys to answer both the things here. Okay, try to answer both the things. I'm giving you some time. I'm drinking water now, so use this time, guys, and try to tell me the answer. What is the maximum possible frequency? What is the maximum possible frequency and what is the, what we say, maximum frequency element? Also, guys, let me give you one more homework, which is the minimum frequency and minimum frequency element. So get this done for me and then we start with our procedure. Charging got a bit low, so let me fix it for you people. I teach so much and create so many high quality course videos that it does happen. Maximum frequency is what? 2 now? 1, 2, 3, 4, 5. What is the minimum frequency? One time number is coming. What is the maximum frequency element? 2. What is the minimum frequency element? You can either write 3 or 4 or 5. All of them are coming for one time. So you can write 3 as the answer or 4 as the answer, or you can write 5 as the answer, does not matter. So what you will do is that when you are calculating the count, you will also store the number. You first calculate count of this is what? 5. You calculate count of this is what? 5. So along with the count, also store which number had this count. So 1 is the number which had this count. 1 is the number which had this count. Here the count is what? 5. 1 is the number which had this count. Here the count is what? Sorry. For 1 the count was 3. For 1 the count is what? 3. For 1 the count is 3. For 1 the count is 3. For 2 the count is 5. So once you know the count, you should also know which number created this count. 1 is that number which created that count. And for 5, 2 is the number which created that count. So whenever you are taking maximum of the count, whichever count is giving you the maximum number, note down its number also, the number which gave that maximum count, and the job is done. I will show you the code and you will understand how the things are going. You have done the HackerRank code, so this will not be very difficult for you. Okay, so just chill out. Let's check the C++, Java and Python codes now. Okay, come around. So C++ code is here for us. Okay, so we took the input nicely, just like last time. I calculated the count. Now, if the count is less than the global frequency, I update my minimum frequency, but I also update what is the minimum frequency element with that. And if the count is greater than max frequency, I update the max frequency, but I also take care of which element gave that max frequency. So I'm able to print the min element, min frequency, max element, max frequency. Okay. So guys, just now you saw the C++ code. The Java and Python codes are very, very similar. So let's check them out. Ram Ram. So Java code. So guys, in Java code also we can see something very useful. Exactly same thing done. Okay, taken the input a of I. Okay, all this is very good. Then for min and max frequency, guys, we calculated min and max frequency, but whenever count is less than min frequency, I update the min frequency, but I also store which element is giving that min frequency. When count is greater than max frequency, I store the max frequency, but I also update which element is giving that max frequency, and I print minimum element frequency, minimum element which gives that frequency along with minimum frequency, maximum element which gives the maximum frequency, element which gives the maximum frequency along with maximum frequency, and element which gives minimum frequency is called as min element with the minimum frequency, element which gives maximum frequency along with max frequency. Okay, so element. So we just enjoy the life. Okay, so these things are clear to you. Now let's talk about the Python thing. Python. So, like in this lovely course, I'm teaching you C++, Java, Python, all three languages because all are predominantly used. So for n guys, the list has been taken. We are just enjoying, we are updating, right? The count, if it is less than the min frequency, then update in the if condition the minimum frequency and the element which is giving minimum frequency. If count is greater than max frequency, update the max frequency and the element which is giving the max frequency. Print the element which gives minimum frequency and min frequency. Print the element which gives maximum frequency and the max frequency. Now, guys, these are O of n squared solutions because there are two nested for loops. These are what? O of n squared solutions. Okay, so let me write here. We are done with the O of n squared solution. Now we want to find O of n solution. Okay, we want to find out O of n solution. Okay, for that we will use a hash map or a hash table or a hash table. Just use a hash map or use a hash table and it's done. So this is nothing but what we were already doing. I will show you. Like the syntax is a little bit different in Java, Python, but don't worry. Whatever array is given to you, na, just convert the array into hash map and the problem is solved. How? Whatever array is given to you, convert that array into hash map. And if you take the input properly, you don't even need to use array. Just use hash map instead of array. Hash map is what? Hash map is a very similar data structure to array. None of the influencers teach you, but today I will tell you hash map is nothing but a type of array only, a very efficient array. Hash map, this is coming after years and years of experience of teaching and solving, is nothing but an efficient array. It only stores the numbers which are required, only stores the number, only stores the numbers which are required. So array has lots of indices, but in our hash map, you can say only those indices are there which are the actual numbers required to be stored. Okay. So let's check out what I'm trying to say. I give you any array, you have to create the hash map of it now. Okay. What will be the hash map of this array? Hash map looks like this. Okay. Left side values are called as the key and the right side values are called as the values, and let's say the hash map k. Name of the hash map is k and the left side are keys and right sides are value. Key means write all the distinct elements, unique elements of this array. They are what? 1, 2, 3, 4. 1, 2, 3, 4. How many times 1 is coming in this array? 2 times. So key is 1. What is the value of 1? 2. How many times 2 is coming in this array? 1 time. So 2 is pointing to 1. 3 is coming how many times? 2 times. 3 is pointing to 2. 4 is coming how many times? 4 is pointing to 1. So this hash map is like an array only where k of 1 is 2, k of 2 is 1, k of 3 is 2, and k of 4 is 1. So what am I trying to say? Listen, I really want to explain this to you in very much detail. You will be very, very happy now. Whatever array I give it to you now, take it in your mind, convert it to a hash map. That's it. That's it. Hash map has keys on the left, values on the right. So what are the keys? Keys are nothing but the distinct elements of that particular array. So the distinct elements are 1, 2, 3, 4. Value is nothing but the frequency of those guys. Frequencies are computed somehow. How they are computed, we will talk about it later. So 1 is coming 2 times, right? 2 is coming for 1 time, 3 is coming for 2 times, 4 is coming for 1 time. So k of 1 tells you what? K of 1 tells you the frequency of 1 in this array. K of 2 is nothing but what? This thing. Frequency of 2 in the array. K of 3 tells you the frequency of 3 in the array. K of 4 tells you the frequency of 4 in the array. So hash map k. Okay. Hash map k. Like let me write here. Use hash map to store the frequency of elements where key will be the array element. So what we do is we have some hash map. and there is the key here, and then there is the value here, and then there is the k here. Okay, and what we are doing is k of number is able to tell us the frequency of number in the original array or set of numbers given to us. Okay, so k of number is able to tell us the frequency of number in the original array or set of numbers given to us. Okay guys, okay, this is clear to you and you are also enjoying it a lot. Even I am enjoying it a lot. Okay, so now what you will do is travel all the keys of your hash map and find out max frequency, min frequency, and the other required data, which is max frequency element, min frequency element, and the other required data. So what do I mean by this? Once you have this hash map, you can just travel and check now. 1 is coming for how many times? 2 is coming for how many times? This. So you can take the max of this. Max frequency is what? 2. What is min? 1. And you can also see which guy gave that max frequency. You just need to travel your hash map. So guys, question is fully solved. There are only two steps. First step is creation of hash map. First you will creation of hash map, HP. You will travel this array from left to right and you will create this hash map. How to create? We are going to look at it. Second thing is travel the full hash map. So guys, if the length of this array is n, the creation of hash map is going to take O of n time, because as you see an element, you will put it in the hash map. Okay. And then you again have to travel this full hash map, and the hash map size can also be n if there were all distinct elements 1, 2, 3, 4, 5, 6. Let's say this was the array. Then there would be 6 keys in the hash map. So hash map would have 6 keys. So 6 is the size, right? You can say 6 into 12 because there is a value also. But in general, 6 ka figure you can get it, right? Because we do multiply it by 2, 6 into 12, but 2 is a constant, no need to consider. So traveling the hash map can also take, in the worst case, it will take in general O of n time. So total, how many operations is it taking you? O of 2n operations. How many operations? O of 2n. But in time complexity calculations, as taught per my older videos, constant is ignored and it becomes O of n. Clear to you people, right? Now we will see how do we do the creation of hash map in C++, Java and Python. So this is the key, this is the value. Initially the hash map is empty. This is the hash map k. Okay. Okay guys? Yes sir. So now all which is left to be done is enjoyment. Life is nothing but enjoyment. So just enjoy and chill out. Just enjoy and chill out. Okay. So yeah. You will please know that in C++ you call your hash map as unordered map. In Java you call it as hash map. In Python you call it as dictionary, DICT. Whenever you have any doubt, just message me on WhatsApp or comment or do something and let me know. I will clear up your doubt. Okay. So guys, the declaration of hash maps are different, and even if you are studying with a specific language, it is very, very better. Like in my media.net interview, I got asked about the internal working of hash map, tree map in C++, Java and other languages, mainly in C++ versus Java. So it's very important to know how the hash map is working in other languages and how to declare them, because it does get asked in the interview, right? Trying to become stronger these days, you can see, right? Yeah. So okay, so now guys, listen to me very carefully. Okay, so first you travel this number 1, then what happens? You see 1, you put here 1, and 1 is coming how many times? 1 time. So 1 pointing to 1. Okay, then you see 2, 2 coming how many time here? 1 time. So 2 coming 1 time. Then you see 1 again, but you see 1 is already in the hash map. 1 is coming for how many times? 1 time. But now 1 is coming for 1 more time. So you will add 1 here. So now 1 will say that 1 is coming for 2 times. Okay. Now you see a 3 here. It will say 3. 3 is not there. So if something is not there, you say that it is coming for the first time. But when you see 3 again, you see 3 is already there for 1 time. So you will add 1 here and it will be 3 coming for 2 times. And 4 coming for first time. So 4 coming for first time. So whenever you are updating the values, it takes O of 1 time in average. When you went here and you put it in the hash map, it took O of 1 time. This took O of 1 time. This took O of 1 time. This is the average time it takes. O of 1 time, we are doing this thing for n times. So creation of hash map takes n times. Space complexity will be also be O of n in general because there can be n distinct elements in your hash map. In this case, there are not n distinct elements. There are like n minus 2 distinct elements here. But in the worst case, O of n. And guys, the average time complexity to create. If someone asks you, what is the average time complexity for creation of hash map in C++, Java, Python, your answer will be O of n. Because to take this number and put in the hash map or update its frequency, when the number is totally new, you are doing insertion of that number in the hash map. 1 coming 1 time, this is called as insertion. It takes O of 1 time. When you are updating the frequency, let's say 1 came for the second time, then 1 was showing 2. So earlier 1 was showing 1, but now 1 is showing 2. This process also takes O of 1 time. This is called as the updation process. So insertion process takes O of 1 time. Updation process also takes O of 1 time in the hash map. So at each element, you're either inserting or updating. So it's taking O of n time in total for the creation of hash map. That is the average time complexity. Worst case time complexity can be, which never happens. Worst case never happens. Worst case does not happen in 99.9% cases. In C++, Java, Python, we will discuss this theory in detail, don't worry. But generally, it does not happen in 99.9% cases. So you do not need to worry about it, okay? So in worst case, the insertion and the updation can take O of n. Insertion and updation O of n, O of n, O of n, where O of n can be the current size of the hash map. But in worst case, the current size can be very big. So that's why we are saying O of n. Obviously, when you are inserting the first element, it is never going to be O of n. But on an average, let's say you have inserted I elements already. Now, when you are trying to insert the I plus 1th element, you can say that it can take O of I time complexity, where I is the current size of the hash map if there are I distinct elements or something. So I am just trying to go to the worst case. In worst case, it can take O of n time, basically the size of the hash map which is there currently. And does not mean the final hash map. The current hash map उसकी कोई भी साइज होगी उसको भी मैक्सिमाइज करके हमने O of n बोल दिया है, ठीक है? n क्योंकि सबसे बड़ा हो सकता है, because n can be the biggest, right? So in the worst case, it can take lots of time to insert or update the element, but it never happens. We always assume the average case of O of 1, okay? So if average case is O of 1, then the average total time complexity of creation of hash map will be O of n. And the worst case time complexity for creation of hash map will be n square, but it never happens. Never happens in C++, Java, Python. 99.9% cases never happens. If the collision happens, then there are ways to deal with the collision also. Now guys, once the creation is done, traveling of hash map you can do in O of n. Just travel all these keys from starting iterator, like this is the iterator. Go from here till the end. This is called as in C++ iterator dash first. And this is called as iterator dash second. So for each number, you will know the number and the frequency. If you know that, you can calculate the min max immediately, guys. Now let's check the C++ code. So C++ code, okay. See guys, you can see insert, update, even accessing values, because sometimes we need to check what is k of number. All takes O of 1 average in C++, unordered map, Java hash map, Python dictionary. Worst case can be O of n, but it never happens. Why worst case O of n? All of them are hash tables. Worst case can happen when too many collisions or bad hash function. Everything goes into one big bucket, becomes a list. That is the internal working of a hash map. Internal difference is very important for interview. C++ unordered map uses separate chaining. It's like a hash table using separate chaining. Worst case attacks possible, code forces hacks, slower than map sometimes due to collision. Maps takes log n time, right? Per access update or something like per update. Can use custom hash to avoid hacking. Obviously, Java hash map uses array plus linked list. But since Java 8, इतना डिटेल में आपको कोई नहीं बताएगा. But since Java 8, if collisions greater than threshold, then it converts to a red black tree. So the worst case is actually log n from Java 8 version instead of O of n. This is a big advantage. In Java, you can never get TLE. Python dictionary, it does have O of n worst case, but it never happens because it is having open addressing probing method in C Python. C Python is nothing but the version, if you are using Python 3 or advanced than Python 3, then guys, there is randomized hashing which prevents hacking. Okay, so don't need to worry. Very stable. It degrades even a very little bit, and it very rarely degrades because there is randomized hashing, and there is this C Python. It is very optimized using open addressing and randomized hashing. So very rare. In C++, there is a case where you can get O of n worst case, but that will also not happen if you use a customized hashing. Okay. Now guys, time complexity O of n for inserting n elements in the array. Inserting or updating n elements for loop for the comparison and accessing the hash map elements. So 2 into n. So guys, let's check the time complexity as there can store n, as hash map stores n distinct elements in worst case. Okay, like even if I don't write can store, as hash map can store n distinct elements. In space complexity, you never take the average case or something like that. In space complexity, go with the worst case. In time complexity, if the average case is happening for way too many cases, then we turn it only as our main time complexity rather than thinking of the worst case. Okay, we need to be optimistic, right? So C++ code, if I try to show you, guys, you can see here a very nice thing now is that we know intents in and no array needed to store the elements. You can use array to store the elements if question requires it. Now we are storing elements in hash map, hence array is not required currently. Unordered map you take, and I take the input. As I get the y value, I update in my unordered map k of y equal to k of y plus 1. Or you can write k of y plus plus. This is updating this key value with plus 1 frequency in the unordered map or my hash table k. Mean frequency I know, max frequency I know. Iterator is going from k dot begin to k dot end. Count is the iterator dash second, and number, the actual number is this. So guys, you know what happens in the count condition and the number condition, and it's done. Okay, it's just done. So now let's go through the Java and Python code. I hope you are liking this in-depth tutorial and high quality codes. Java, I take, but guys, in Java, to update, see, when you are creating the hash map, you have to write this line k dot put. If that number has never come before, then the value of 0 will be assigned and then 1 will be added. So y will be pointing to 1. If that number has already come, then whatever is its current frequency plus 1. Okay. And then guys, you travel the hash map like, see, you declare the hash map like this, hash map integer hash map. And you travel the hash map like this, map dot entry integer iterator k dot entry set. The number is get key and count is get value, and you know what to do, right? Now let's check the Python codes and then we can end the session. Then I will show you some interesting things which other educators and creators don't show you. So that will be added as the next part of this lovely lecture. So let's go. Python. So in Python, guys, same thing. K dictionary, k of y equal to k dot get y 0 plus 1. This technique you have to write. This means that whatever is the frequency, current frequency of y, add 1 to it. And if the current frequency, if y does not exist, then assume the current frequency to be 0 and add 1. So y will be pointing to 1 if y is coming for the first time in the array when we are traveling from left to right. And guys, just in this k dot, in this dictionary, write this syntax, k dot items, number, comma, count. So number, comma, count will immediately tell you what is the left key. Number is the left key and count is the right value. So you know when you have the count and number what to do, and it's done. Okay. Guys, make sure you don't stop now. Now comes the most important part. How can we use tree maps, which has log n feature, and it helps in C++ a lot because O of n worst case will not be available. And how can we just use an array of size 500 and do all these similar things? Because array Hash map is nothing but an efficient array. So you can just sometimes use array. It is very helpful in code forces problems and high paying companies online assessment problems to make sure you don't have too much memory and time complexity. The actual practical time, see, the theoretical time complexity will remain same, but the actual number of operations and the time required can be reduced if you sometimes use array instead of hash maps or hash tables. Hash table is nothing but our hash map only. So arrays can also be used as hash map or hash tables. So Ram Ram, let's meet you in the last part. So stay tuned. Ram Ram. Welcome. In this video, we are going to do something very, very important. So what we are going to do in the third part of this lecture is that I want to show you that whatever we did using unordered map in C++, right? Hash map, we call it as hash map in Java, and we call it as dictionary in Python, right? The same thing we can do using map in C++ and tree map in Java. The complexity will increase till it is a good option, and that's what I want to explain you. So if I open the codes, nothing is different here. Nothing is different in the code. Just instead of unordered map, I have written a map here. Rest all is same, okay? Rest all is same, guys, okay? Now, same goes for Java. If I try to show you the Java code, instead of hash map, I have declared it as tree map, okay? So guys, I wanted to explain to you what are the changes happening when we do things like this, okay? So let's go to the sketchpad for better understanding, okay? So see, what were we doing earlier? Okay, let's try to make sense of it, okay? So in C++, we were using what? Unordered map, UMap. In Java, we were using hash map. In Python, we were using dictionary. Average cases were what? Average time complexity were O of 1, O of 1, O of 1. And in the worst case, the C++ thing could go to O of n. Java could go to O of n or O of log n and or O of log n depending on which version of Java you are using. If you are using version of Java 8 or after that, then only O of log n. And this also in worst case can go to O of n. Right? Python uses chaining, so the probability is very low, but yeah, in worst case it can go to O of n. You can always, like, even though you're watching this video now, always do research, like keep on researching the recent versions of C++, Java, Python, and see what are the average case and worst case of hash maps and tree maps, unordered map, ordered map, and dictionary in them. That way you will always have the exact knowledge as per the current version, because you might be watching this video after 10 years, okay? And after 10 years it could happen that all the versions are having even the worst case as O of log n or O of 1 or something like that. That's why, okay? But for now, this is the scenario, right? But if you replace this C++ unordered map by a normal map and Java 1, you replace it by tree map, T map. Okay, let's call it as tree map. Then guys, the average case for both of them will be O of log n. But the worst case will also be O of log n. So this is called as balanced risk. Why this is balanced risk? Yes, I agree that average case is not good as O of 1 because log n is a number bigger than 1, right? Average case is not that good with the map and tree map. But worst case, dekho. Worst case is log n. Here the worst case was O of n. And here the worst case is log n only. Here the worst case could be O of n or O of log n, but here it is log n only. We know that n is very much greater than log n and log n is greater than 1. So even though your average time complexity has increased a little bit, worst case time complexity has gone from O of n, a big number, to O of log n. And you will say, sir, in Python, why are you not doing? Guys, in Python, we do not have any indirect inbuilt library which can work like a sorted map. What is a sorted map? Sorted map is called as map in C++ and tree map in Java, but in Python, it does not exist. You can use some calling of some special libraries, but direct inbuilt library does not exist in Python. So you cannot just declare something in Python as a sorted dictionary and get it done. No, you cannot declare it directly. There are ways to do that, but you cannot declare it directly in one line. Okay. So complexity thing you can read here, whatever I have shown it to you. Okay. and they internally generally use red black tree, and they are always balanced. Okay, so these things are getting clear to you, and it's very nice. Now let's go below. Let's go below, guys. A very important follow up I want to teach you, which most of the like teachers don't teach generally. How would you solve this question if it was given that the input elements only have their lengths less than equal to 500? So before I go to that part, listen to me very carefully now, okay? If array is given to you like this, a normal map would look like this. It would say 1 coming for one time, 3 coming for one time, 2 coming for two time, 4 coming for two time. But a sorted map is what map? It maintains the keys in sorted order. It is called as map in C++, and it is called as tree map. It is called as tree map in Java. If you put these elements in a tree map or a map in C++, it will show these keys in sorted order. It will say 1 is coming one time, but then it will take 2. This will be sorted. After 1, 2. It will tell the frequency of 2 only, then frequency of 3, then frequency of 4. So if the left hand side, guys, this is the key, this is the value. If the keys are sorted, then you call it as a sorted map. Okay. So guys, now the question is, if the array input values, let's say an array A is given to you, okay, and it is known that all the array elements will be from 0 to 500. Is there any other way to solve the question? Let's say your array look like this: 1 5 8 1 2 0. One way is what? To solve the same question, to get the maximum and minimum frequency, just make a hash map of it, right? 1 coming for 2 times, 5 coming for 1 time, 8 coming for 1 time, 2 coming for 1 time, 0 coming for 1 time. And you just check the maximum frequency, minimum frequency. Another way is just use array as a hash map. Another solution, we use it a lot in online assessments and competitive programming. I told you, in this course, I will prepare you for non-standard questions also of online assessments. Even the non-standard follow-ups like this can be asked in interviews, and competitive programming it is used. Use this, create a new array called as a B array and declare a B array empty array of size 501. Use this B array as a hash map. What am I trying to say? We will declare a B array and its size will be 501. So there is this B array like this, okay? It is like this. This is 0th index. This is first. This is such a lovely concept. I love teaching you these things. 3rd index, 4th index, 5th index, 6th index, 7th index, 8th index. And like these, the elements are there. Okay, like this, the elements are there. This is array A is given to you. You are creating the B array. Now your hash map is B only actually. How? All the elements inside this now. All the elements inside this are filled with zeros. Okay. So just let me see if I can fix it up. So just let me see if it is okay. Okay. So like let's make the array as 1 2 4 3 2. Okay. And I have declared a B array, okay, of 500 size. I'm not showing the entire 500 thing, but you get the idea, right? 0 index, 1 index, 2 index, 3 index, 4 index, like this till the last index is 500. As soon as initially all the values inside the B array are 0. As soon as you see 1, what you will do? B of 1 equal to B of 1 plus 1. It will give the same effect as a hash map. In B of 0, now we will be putting what? We will be putting a 1 here. And for b of 2 equal to b of 2 plus 1, so okay, sorry, b of 1 equal to b of 1 plus 1, so this is b of 1, so here I will put a 1. B of 2 is b of 2 plus 1, so here also I will put a 1. B of 4 is b of 4 plus 1, so here also I will put 1. B of 3 is b of 3 of 1, so here also I put 1, and rest of the elements stay 0. B of 2 is b of 2 plus 1, so b of 2, one more will be getting added, it will become 2. So now the array will look like this: index 0 0, index 1 1, index 2 2, index 3 1, index 4 1, index 5 0 0 0. So guys, b of I will tell me the frequency of I in the original array. B of I is able to now tell me the frequency of how many times B of 1 tells me how many times 1 came in this array. B of 2 tells me how many times 2 came in this array. B of 3, B of 4, so it is just acting like a hash map. These left indices are nothing but the keys and the values are this. So B of I may, such a lovely concept. If you have a new array B of size, declare a new B array of size 501 array, okay? This I is nothing but these are the key, the indices are the key, and B of I is the value. I is the key and B of I is the value. That's it, guys. Okay. So just think about it, how great this is going. Okay. This is going really great. Okay. Really great. So everything is good in this option. So what will be the time complexity? Average case and worst case, both will be O of 1 only per operation. So totally it will be O of n. In an array, if you update an element or check the value, it's O of 1. And if you're doing n operations, O of n. Space complexity is a little bit of an issue. Why? So in this method, now you must be thinking that, sir, if array is so good, if array is such a good data structure, array is able to act like a hash map or a hash table, right? If array is able to act like a hash table, hash map, then why are we not using array? Why are we using hash map? A valid question which should come in your mind. Because when you used array, you had to fix a space. You had to declare an array of size 500. So it took O of 500 space. Because you were assured that the input elements of the array will be from 0 to 500. That's why you declared this as 500. Okay. So this large space is being taken. But if you were using hash map, you would only take O of 4 space. How? Hash map would look like this, na? 1 coming one time, 2 coming one time, 3 coming one time, 4 coming one time. So hash map only took O of 4 space. But array, you don't know. In array, everything is from I to B of I. So we don't know what can be the I value. So if the input is telling that the values can be from 0 to 500, you have to make an array from 0 to 500. Even if in the input there is no 500 number, for safety purpose, array is, you create array of fixed sizes now. So you have to allocate that space. So it is not space optimized solution. It is not a good solution, efficient solution. If you're trying to optimize space, that's why in hash map what happens is that the keys, the indices we decide and we put those values. The indices which are not in use, we don't even use them in a hash map. So hash map is actually better than array in many cases. Space efficient it is. Coming to time efficiency, they are almost the same because O of 1 average is there also. Yeah, but the worst case can go to O of n or O of log n in hash maps, tree maps. But in array, the worst case is also O of 1. But in array, the space required is more. So make sure you discuss like this with the interviewer. But in this case, the array elements could only be from 0 to 500. What if the array elements could be from 0 to 10 raised to 5? Then you would have to declare an array of size 10 raised to 5 plus 1. What if there would be negative elements? Then this approach would not be easily possible because array cannot have negative elements. You would have to create another array to handle negative elements. Array C, if there was a -2, you would store it in C of 2 and you would assume that C array stores the negative elements. So yes, you can do many things, but array has these issues. I know no one generally teaches things in this much depth, but I'm covering it because it will make you stronger. And we will get the daily selections of you people. Okay. So guys, O of 500, we can say the space complexity. I have written it as O of 1, which means a constant space because the space is predefined. But in actuality, space is predefined. That's why I'm writing O of 1. But this could be as large as 10 raised to 5. Yes, you can write that also as O of 1 because 10 raised to 5 is a constant number. But in practicality, it is not efficient. O of 1 looks good. But in reality, if you use let's say the array size is 10 raised to 5. It is taking 10 raised to 5 places in the memory. Okay, so in practically it is taking 10 raised to 5 places. So practically it is not good. 500 it is still small, but 10 raised to 5 will be very big. And guys, do you know this approach is not good in one more case? What if the array elements could be as big as 10 raised to 7, 10 raised to 8, 10 raised to 9, 10 raised to 10? You cannot declare an array of size 10 raised to 10. Array maximum you can declare only till 10 raised to 6, 10 raised to 7 size, not more than that, or else you will get runtime error in your single program. In general, like this thing is not generally shared with students, but I'm doing this because you are doing from the brilliant, lovely course of ours. In general, 10 raised to 7 is the max limit. Never try to declare an array of size more than that. If range is small, guys, of that number 0 to 500, if that is a smaller range, array beats everything. Map, unordered map, tree map. Okay. Hopefully you like this course and the third part of the lecture. Ram Ram. So happy to teach you all. Ram Ram.